Double slips and single slips. What are they all about then? Hi, welcome back to Chadwick TMD. I'm Charlie. So, double slips and single slips, what are they all about? Well, you'll find them predominantly at the entrances to railway stations and goods yards, and they're used by railway companies to improve the functionality of the junction in a much more restricted space. I think it'd be fair to say that most railway companies don't like double and single slips. They're harder to maintain, but it's a necessary evil. Here we can see various double slips and single slips, and you can see they're a nice thing to look at. And looking at back to our own model railways, they kind of give it an improved point of interest. They make the lines look much more complex and improves the running characteristics and make the layout much more interesting. In this video, I'm only looking at Pico electro-frog double and single slip points. I'm not looking at the insual frog points, and all the Pico electro-frog points are code 75. So if you're a code 100 person, you need to use these, as I do, then you'll need to use code 100 to 75 converters as you come up to the junctions, which are small pieces of track or a special kind of fish plate. So what I'm not concerned with is the new Pico uni-frog point system. That's not what I'm looking into here. Okay, let's go. And just in case you're worried whether your trains will actually go around a double slip or a single slip, the dimensions are very similar to that of a long crossing. And that is, if you pop a track setter on there, and you can see that it's actually a 24-inch radius around the slip. So they're all identical, exactly the same dimensions. And if 24 inch doesn't mean much to you, then a fourth radius curve is 22.5 inches. So everything will go around a fourth radius, and so everything should go around your crossings. So moving on, what's the actual differences between a double slip and a single slip? And this is a double slip straight out of the packet. Well, put quite simply, on the double slip you can come in there and out either of those. Same with that, same with that, same with that. There's no restriction. Whichever one you come in, you can come out. Whereas on a single slip it's not quite the same, in as much as you can go straight across either one, but you will only be able to go around the bend of one side and not the other. Well, why on earth would you want to do that? Well, into the fundamentals of sort of railway work. So that's now our up line. A couple of arrows on there. And this is our down line. A couple of arrows on there. So if we wanted to go from our up line across our down line into our station, how would we do that? Well, quite simply, as you'd expect, we would install a couple of points. Here's a little head shunt. Just extend those on a bit. So you will have a left-hand point, a right-hand point to come around there. Then you'll come across your double slip, which would be in this area, and then you would come across another right-hand point into the station. Now the problem with using a double slip is that the train could, in the event of a point failure, come across this point and turn up onto the down line. Whereas if you use a single slip, then this option isn't open to you. The train can only go straight across, and coming in the opposite direction it can go around. So this track here is always live, and that one there is always available, but never can you go from here to here, and that's the advantages of using a single slip. On your railway, however, you might say, well, why do I want to do that? Just use a double slip everywhere and not a single slip. Well, it's because you might want yours to look a little bit more prototypical, and that's the main reason. So in reality, it's a safety feature, and it also, of course, leads to less maintenance. But from your own model railway point of view, you may choose to use a double slip instead of a single, but that's what they're about. So now moving on, what on earth are double slips and why do we have to use them in such a manner? Well, the way I've kind of looked at it is double slips are basically 2 points end to end. Except, of course, they've compressed the size as you would going into a railway station. Now, you have the tie bars here and here which switch the rails. And here, they're kind of different. Now, if you read the instructions, it mentions that on a double slip, you connect this frog to this point motor and this frog to this point motor, which seems a kind of the wrong way around. But that's because they're constructed in such a way as they're not like this, they're actually mounted like that. And that's the way that single and double slips work. The tie bar is the opposite end. So the tie bar for this point is located past the other tie bar, if that kind of make any sense at all. Which is why when you read the instructions, a lot of people get lost in the connection of the frogs. You'll also find with the double slip there are 4 cables when you take it out of the packet. Now this cable here, this wire here, is obviously for this frog and is connected to this point. This one here is for this frog and is connected to this point motor, and these 2 are the power feeds for the point itself. Now there's no way I can show you how to wire up your products because you could be using tortoise or cobalt or servos or seeps, or indeed, as I've done in the past, Pico products. And so I'm unaware really of the fundamentals that work with those individual point motors. What I can say, however, is in accordance with the instructions on the back of the point motor, you do need to fit insulated rail joiners to each and every rail connection, whether you're working in DC or DCC. So just for a change, there's no difference. The instructions are reasonably sort of precise, but what I'll show you now is how I did it on the original Chadwick TMD. Please excuse the standard of soldering. It's improved in those days, let's just say. But in the original Chadwick TMD, I'd used seat motors, I'd used Pico point motors all over, and I didn't have many main problems. The only thing I didn't like about them eventually was the thudding noise, which is why I've tended to move on to tortoise. But there should be a link here for to see the full video that I did when I first started out with Chadwick, and hopefully that will kind of make sense. So the double slip is located down the far end, just to the right of a signal gantry, and hopefully between the arrows, and you can see where it is. Here's the underside of Chadwick TMD's left-hand board, and to the left-hand side of that Digitrax unit you can see 2 Pico PL15 switches, and they're mounted underneath the point motors, which are PL10s. If I offer up the double slip which I've been showing you, that's where it is. The 4 cables here, all my frog cables are always in green. So here's the frog cable from this side. It routes around, goes up to there. This one comes from the top and then routes around into the second switch. The red and the black are obviously the power feeds that go into the switches to switch the frogs. The yellow and blue cables are the power feeds running in to each of the point motors. So let's say you throw the point and the power goes in on the yellow, it throws the point and then comes back out on the white. Similarly, if you throw it the other way, the power will go in on the blue and again comes back on the white. And when the point motor changes over, the switch then changes the feed to the frog from the red to the black. So the correct polarity is always maintained on the frog. And finally, you need to power the track itself, and then I have one black cable going in and then one red cable going in to power the actual tracks themselves. I'm sure if you're using these Pico products that your wiring colouring is going to be different, but hopefully from this you can understand how I've done it, and if you get stuck then perhaps it will throw some light on your snag. Now here's a different angle just in case it helps if you do get a wiring snag, and this is how I've kind of wired mine up in there nice and close. Of course, if your points throw in the opposite direction or the frogs, you know, the wrong way around, it's just a case of changing the cables over until you get it right. The best thing to do is figure it out so that your points throw first, and once you've got those operating correctly, then sort of connect the frogs up to make sure they work right. And if you find that the frogs, the polarity is continually wrong, then all you need to do is to reverse these two cables. If you switch this red and the black the other way around, then you get the other feed on this cable then, which goes up and supplies the top frog, and then obviously vice versa from there. Well, hopefully that's given you an insight in how you can incorporate single and double slips into your layout just as they are in the real world. It's not necessarily an easy thing to do, but if you do bring in a double or a single slip, it certainly expands the kind of workability of your layout. It makes it much more interesting. Hopefully there should be a link up here to another YouTuber who specialises in very, very intricate point work. And some of his stuff is kind of breathtaking, really. It really is good. But it doesn't come easy. The wiring is very complex, and he hacks around his double slips and his three-way points, etc. And he really cuts them up to make them gel together in such a manner. But there we go. So that wraps it up. Until the next time. In the meantime, if you're a patron, thank you very much indeed, and there should be a link there if you're not, and there should be something to subscribe. And remember, there's always a bell you can ring so you get an alert to my next video. So there should be a video here, and I'll see you at the next one. Thanks a lot, take care, and bye-bye.